Today we're going to focus on 9.3 nonlinear systems of equations. So in order to solve nonlinear systems of equations, or what is a nonlinear system, it's a system in which one or more of the equations is not a linear equation. And we can solve by using substitution or elimination just like we would if they were linear systems or linear equations. So the first example we're going to look at is 5x plus y equals 3 and y equals x squared minus 3x minus 5. So what we should notice is this first equation here, that's linear, but the second equation, that's nonlinear. That's a quadratic. So we're going to find, or we're going to solve the system between a quadratic and a line, okay? All right, so what we should notice is this y is all by itself. So we can solve by substitution in this case. We can make a substitution for y and plug this whole thing in for the y in our first equation. So we get 5x plus x squared minus 3x minus 5 equals 3. So now we have one equation with one variable, all with x. And so we have ourselves a quadratic. So what we need to do is gather all of our like terms onto one side. So subtract the 3 and combine our like terms. And we're at x squared plus 2x minus 8. At that point, we can factor it. X plus 4, x minus 2 equals 0, and we get two x values. So now what we need to do is we need to plug these two x values in and solve for the corresponding y value. Okay, so we can plug those back into either equation, but I think it might be easier to plug into the top one. So I plug in when x equals negative 4, 5 times negative 4 plus y equals 3, and we end up getting y equals 23. So that gives us our first solution, negative 4, comma 23. When we plug 2 in for x and we work through it, we'll get y equals negative 7. So that gives us our second solution. So in this case, when we're dealing with nonlinear equations or nonlinear systems, we could have multiple intersection points. Okay, so in this case, the line intersects our parabola at 2 points, negative 4, 23, and 2, negative 7. And remember, we always state our solutions as ordered pairs. This next example, where we're going to solve the system, what we should notice is we have an x squared and a y squared in both of the equations. So our best bet here is to use elimination. We'll get rid of one of the x squareds or y squareds, okay, one of the variables, and we'll be left with one equation with one variable. So what I did was I multiplied this second equation by negative 2 so that I can cancel my x's out. So by multiplying this whole thing by negative 2, we get negative 2x squared minus 4y squared, and then 12 times negative 2 is where the negative 24 comes from. Now we're going to add these two equations together, and our x squareds cancel. 3y squared minus 4y squared is where we get the negative y squared equals negative 3. So dividing by negative 1, we get y squared equals 3. And then to get y by itself, we have to take the square root of both sides, but don't forget about that plus or minus. So we really get two solutions for y. Y equals positive root 3 and y equals negative root 3. And so now we have to plug both of those values in to one of the original equations to solve for x. When we plug root 3 in for y, I just plugged it into the second equation. We get x squared plus 2 times the quantity root 3 squared equals 12. Well, root 3 squared is simply 3, and then 2 times 3 is where we get 6 from. So we get x squared plus 6 equals 12. So x squared equals 6. When we get x by itself, by taking the square root of both sides, we have to remember that plus or minus. So we get x equals plus or minus root 6. So that tells us we actually have two solutions when y equals the square root of 3. We get the square root of 6 comma square root of 3 and negative root 6 comma root 3. So now when we plug in the negative root 3 in for y and we go through and solve, you can see that we get plus or minus root 6 again. So that tells us we have two more solutions. We have two x values when y equals negative root 3. So we get root 6 negative root 3 and negative root 6 negative root 3. So we end up with 4 intersections between these two equations. Let's look at this last example really quickly. Again, I notice I have an x squared and a y squared in both equations, so we can use elimination again. Looking at it, you can decide which variable you want to eliminate. I tried to eliminate x's by multiplying this bottom equation by negative 4. So x squared times negative 4 is where we got negative 4x squared. Negative y squared times negative 4 is positive 4y squared. And 25 times negative 4 is negative 100. So when we add these together, we end up with 9y squared plus 4y squared, so 13y squared. 36 plus a negative 100 is negative 64. If we were to continue to solve this, we would get y squared equals a negative 64 over 13. Well, why can't this be? Well, whenever we take a value of y and we square it, we're always going to get a positive. It can never equal a negative, okay? So y squared can't ever be negative. So therefore, I can make the conclusion right away that this is no solution. I'm done because this doesn't work out. No matter what value I get for y, after I square it, it will never equal a negative. So we're done. No solution on this guy. If you have questions on nonlinear equations, systems of nonlinear equations, let me know.